Okay, so the goal of this panel is to help students and professionals interested in data science learn about this field and have the opportunity to ask questions about career paths. And luckily for us, we have 4 incredible panelists currently working in a variety of roles related to data science, and they have generously agreed to tell us about their experiences. They are also eager to answer any of your questions. So as you have questions or thoughts about today's panel, go ahead and pop them in the chat and we'll get to that. Okay, so first up in alphabetical order is Jeff Kline. Jeff is a data scientist at American Family Insurance. Jeff earned his PhD in mathematics from the University of Wisconsin-Madison, and he currently lives in Madison. Jeff's work experiences include a postdoc with the LIGO project, a Madison-based startup, remote work before it was normal, and he has published on a range of topics, including convex optimization, machine learning, internet measurement, and linear algebra. Dr. Rachel Cummings is an assistant professor in the Department of Industrial Engineering and Operations Research at Columbia University. Her research focuses on data privacy with connections to optimization, statistics, machine learning, and public policy. Sarah Kermis graduated in 2019 with her undergrad in industrial engineering and a certificate in computer science. She is now a solutions architect at Amazon Web Services, where she has been in her role for 1.5 years, helping customers architect innovative solutions in the cloud. And finally, Frank Liao is the Director of Data Science and AI at UW Health and an adjunct professor at the Burby Walsh Department of Emergency Medicine in the School of Medicine and Public Health. He received his PhD from the University of California, Berkeley, in the Department of Electrical Engineering and Computer Sciences. His responsibilities include the use of data science to improve and evolve the delivery of clinical care at the front lines of medicine. So those are our 4 panelists, and I'd like to thank them for joining us today. And I'm, for one, am really excited to hear about their experiences working in this field. So the way this is going to work today is I'm going to ask a question and call upon each of the panelists individually to provide their responses. Jason will also post each of the questions into the chat, so you can keep an eye out there for the questions as well. Panelists, feel free to raise your hand anytime to add something to what you've already said or to make a follow-up comment. Audience members, we hope that you will have questions for the panelists, and when you do, please type your questions into the chat. Our Zoom host, Jason, is going to be recording those questions, and towards the end of the session, I will ask as many of the questions as possible on your behalf. Okay, so question number 1. Could you please describe your current role in data science? What kinds of things do you do on an average day, and what do you spend the most time doing? Jeff, could you get us started?
Sure. Thanks for setting this forum up. The current role has evolved from what it used to be. It's far more collegial than it used to be for me, at least. When I started, there was a lot of individual work focusing on well, just for the little bit of context, the industry that I've been working in has changed many times, and like the reason of my employment with these different groups has been changing over time. So when I started, it was more like coding than actual data science, and over time it's become more about finding structure in unstructured data, finding patterns where there is hypothesized to be patterns, and helping others get up to speed on the features and attributes of data that they need to in order to do their kinds of tasks. So the average day is a mixture of our group is a little unusual in that we have both research activities and kind of business-centric activities, and the day-to-day things change from week to week, from kind of operational stuff to more research exploratory stuff. So yeah.
Thank you very much. Professor Cummings.
Yes, thank you. Happy to be here. So for background on kind of my like high level role in the data science field, I'm an academic. My time is split in some fraction between like a teaching, educational activities, and kind of like a research activities. So my teaching, I teach undergraduate courses on things like machine learning algorithms, and that's gonna look like all the like classical things that you learn. I teach those classes. I find that I learn a lot in the process of that teaching as well, and so that's always fun for me. Helps me stay current. On the research side, I work more on the like theoretical aspects, and so I'm less like I'm hands-on with real world data, but rather I'm thinking about like better algorithms that we can design to achieve some of our data science tasks. And I think people are oftentimes a little bit baffled. I'm a kind of like theoretical data scientist, and they ask me like, in what languages do you code, or where do you get your data sets? And I say like, I don't. So it's a bit unusual. But I think this is what happens if you work on the kind of theory side. So I think a lot about someone has a particular analysis task they want to do, and they have a data set. What are the like algorithmic steps they can take to use their data to solve their task, whether it's like machine learning optimization, and then also trying to prove formally and mathematically that like this algorithm is going to perform the task that it's like I'm supposed to, and thinking about runtime, how long will this algorithm take like to run as a function of the input size of your data and things like this, and then also reasoning about the accuracy. And so if you're trying to do some kind of estimation, optimization, understanding how close to the optimal, how close to the ground truth is a thing that you're going to learn at the end of the day, and the hope is that it will be very close. Yeah.
Thank you very much. Sarah.
Finding my mute button. Hi, everyone. Thank you so much for having me today. This is so exciting because it seems like already we have a diverse panel. So what I do is very different from what our other panelists that I've gathered are doing, which is really exciting. So I work as a solutions architect for Amazon Web Services. And for those of you who don't know, Amazon Web Services is a subsidiary of Amazon.com, and we provide cloud computing resources. So for those of you who don't know what cloud computing is, it's a shared on-demand compute resource repository or products with pay-as-you-go pricing. These compute resources can be rapidly provisioned and released with minimal management effort or service provider interaction. So for those of you who are super familiar with data science, right, as I am gathering most of you are, those cloud computing tools are perfect for data science. And data science, in fact, the servers that run, that store data sets, that process large data sets, like the ones that you all work with, oftentimes run on cloud computing servers, such as those that run on Amazon Web Services. So basically what I do is my role is very customer focused. So I work with public sector customers, including K through 12 school districts, state and local government. So anywhere from Wisconsin public health. I'm actually in Texas, so I don't work with Wisconsin, but my customers are large government organizations, and I'm helping them harness the power of the cloud. So just with the nature of my customers and their workloads right now, unfortunately, I don't get to immerse myself in data science every single day because largely my customers are working on things such as migrating to the cloud, using storage products, sometimes implementing data lakes. More and more of our customers are doing so. But I do get the customer every once in a while within public sector that does harness the power of data science, machine learning, artificial intelligence. And I am hopeful that in the future, many of our public organizations will start to do so. We have a lot of examples within my team already of customers using the cloud for things like recognition on the roads, whether it be tolling for departments of transportation, recognizing cars and trucks and billing them accordingly, or in airports, identifying security risks or potential traffic violations using AI. So lots of exciting things happening at Amazon Web Services. My role in particular is very customer focused. And so I'm all over the place in the cloud, helping customers with what they need. I get to dabble in data science once in a while, but the majority of my time is spent in things like migrating to the cloud.
Thank you. Frank.
Hi, everyone. Really happy to be here. I think we do have a really very good, solid group of panelists here, very diverse, as Sarah said. So my role really is that of really moving forward data science for the health system. And so we're an enterprise or centralized group. So we are the data science function for the whole health system, whether that spans like the hospital and doctors and nurses to even finance and people working in the back office. And I would say that my role really largely is more of a leadership role to really move forward both solutions and our technologies related to data science and how data science can be used to improve healthcare. Just a quick comment, right? That wasn't always the case, right? So I did, there was a part of my career where I was mostly, spending the day at the computer, writing code and doing those things. But then now in this current role, it's a very, very small amount of time that I spend actually doing the code, but really supporting the teams that are building the predictive models or building the machine learning algorithms. So my typical day is, I might spend some time talking with our data science team, seeing how things are going. I might talk to our software engineering teams, since we work very closely. And then I spend a lot of time talking with other members of our health system. So our CIO, or I work with other directors, and we coordinate a lot of these pieces because at some level, data science is a team sport. And so we can build the predictive algorithms, but then how do we actually embed the predictive algorithm in our electronic medical record? And so we work with a lot of other teams. Another group that I spend a lot of time with throughout the day talking with are our stakeholders, right? So the people that are using these solutions or the people that are supporting these solutions. And that's a really, really important group for us because one thing that makes our data science approach really unique in the health system is that we are really, really about getting actionable data science solutions in front of people. So for example, prior to when I joined UW Health, there had been a couple predictive analytics projects. A lot of them went to this space where we'll run like a predictive model and we'll put it in a report, right? And let's hope that, maybe some nurses look at a column in a report of patient risk. But what we really try to do, and that's why we call it the applied data science group, is really actually work embedded in the system. And so a lot of times we will do a predictive model that will then fire an alert. So for example, we have one in the ED that fires an alert to the doctor, and the doctor has a protocol by which he or she may then place a referral to basically, in this case, we have a referral to our falls clinic. So the model predicts how likely a patient might fall after they go home, because that's a problem that we have at UW Health. Is actually a general problem for the state of Wisconsin. We have some of the worst outcomes when it comes to older patients going home, having a fall, and then coming back to the ED. So the predictive model predicts whether or not this patient might have that outcome. And then when the provider sees that alert, right, and it happens at the end of the visit when the provider's basically working up the patient. When the provider sees that alert, the provider can then place a referral and get them into our falls clinic, and they can do an evaluation assessment and prevent the patient from having that outcome. And so that's just one example, but we work really hard to make sure that our data science solutions are actionable. So then we can kind of measure, how many patients did the model predict, but then more take it a step further. How many alerts were shown? And of those alerts, how many times did the provider place the referral? And then now we're tracking it all the way to, did the patient then end up in the clinic? Did they schedule the appointment? Did they have that intervention? And so then we can start to see the effect that our predictive model is having on healthcare. And so that's a stakeholder group. So we have to work really closely with people in the ED. We work really closely with the nurses and the doctors there. So that's another group that I might work with or talk with throughout the day. So hopefully that gives you a good overview of a day in the life of.
Thank you very much. A couple of you had mentioned that once there was a lot more coding, but now there's a lot more variety to what you do. So the conception that some people have that data science people tend to just sit behind a computer and code all day, not true?
Absolutely not true. Frank mentioned the word stakeholder. That is a big deal, especially in insurance. The impact of what you're doing affects real lives, and it's only meaningful work if it's actually having an impact on somebody's life. And that impact can be either positive or negative. And sitting behind a computer and running an algorithm and saying, the accuracy was great, let's just go with it. There's a lot of reasons why you wouldn't want to do that. And engaging with stakeholders and understanding who's impacted, who could be impacted either positively or negatively by what you're doing is extremely important. And you can only do that by listening to what other people have to say about what your work is.
Yeah, thanks for pointing out the stakeholder piece, Jeff. I couldn't relate more to that. And just adding on too, I think having the background in some of the tactical items, the coding, the prediction models, for at least for my role, when I'm prescribing those types of solutions for customers, even though I'm not the one that's coding the services for AWS and our algorithms, it really helps to be able to understand what is happening behind the scenes so I can be more prescriptive to my customers.
Yeah, and I'll just add to that, I am probably an outlier in the data science space, but I actually don't even know how to code. It's a little bit embarrassing, but I am a mathematician by training, and so I think a lot about these theoretical aspects. And then I, of course, collaborate with people who do implement these things and think about them. But I think in similar themes to what some of the other panelists mentioned. Of course, there are a good number of data scientists who do code, but it's rather a large team. And there are some people doing the coding and some people doing other things, and I happen to be the other people. And of course, other people include folks who will interact for the stakeholders, as was mentioned.
I would definitely say that there's lots of different types of roles that you can have in data science. And I see Nikki has a question for me, so I'll hit that one too a second. And I don't want to say I have the canonical answer for all the potential things, but I'll just give you a slice or snapshot for our group. There's at least 4 roles, actually maybe 5 I could mention that are helpful. So one was that we have data scientists. And as Jeff was pointing out, these folks also have to work closely with stakeholders. They take a consultative approach. So it isn't just build me this predictive model. A lot of times we have to sit down and talk with the people who are making this request. And one of the things we like to do is do a Mad Lib that says, if you could predict X, I would do Y. And just by having that discussion, you find out, the X that they really wanted isn't what they wanted to predict. But you have to have those discussions to figure out what it is that you're really trying to solve. So those are the data scientists. Then we also have a role in our group called the machine learning engineers. And those are much more of a combination of a software engineer plus a data scientist. They, in a sense, are less consultative, but they're really working on more of a software engineering practice, but they're still doing a lot of work with machine learning. So they're really kind of building the system. If it helps, one way that we explain or talk about it is a data scientist might go to a stakeholder and have that consultative discussion and deliver an answer to that person. A machine learning engineer is still delivering actionable information, but that might be in the form of a recommendation engine. So sort of their target is like a system that then might interact with other people. So you have the data scientists and you have the machine learning engineers, and there's different flavors there with how much you're interacting with people versus how much you're kind of doing straight up coding or programming. A third area we have is an architect role, right? Currently, that's one that we're looking to fill. So just to be, and so that's one that has a lot less coding, but they're really doing like a systems level design. Like, how does the technology stack look today? How does it need to look in the future? And they're really designing a framework by which then our teams can then leverage and use. So that's another important role. And then we have one that this is getting a little bit outside data science, but design thinking. So how do we present this information to end users? And that's a huge question, especially in healthcare, because you can't just fire a model and say, this is red, now do this. Doctors and nurses both want to know. They want to know, how did the model come to this? And there's a whole realm around interpretability of the AI or explainability. So we work really closely with, how do we show the top factors and things like that? How do we present this in a way, especially in the moment when they're at the computer doing something else, that they can quickly process and digest that information and then act on it. And then I'll mention another area, which actually is in a separate area in our, within our organization, but works very closely with us, called data engineering. And those are people that take data and really build pipelines that turn that raw data into processed data that's usable. I just mention it because in the older days, quote unquote, that used to be part of the data science role, at least in terms of how I grew up. But now it's kind of separated out into its own area and building these pipelines. And especially as there's more and more types of data and more volume of data, that role is really important. So how do you get in unstructured data like text data or images and build these pipelines that then process the data and put them in a place where your data scientist or your machine learning engineer can then pick it up and use it from there. So lots and lots of different opportunities. I think it's a really rich space and different ways that you can grow and go. And then second to Nikki's question, so my progression in health systems, actually, this is kind of a maybe unexciting answer, but I came in the role that I have now really with the express purpose of really advancing our data science maturity in the health system. So it was a new position that was created, and it's something that I'd done before a couple times in my career. So at that point, I was already doing more of this type of role of how do you move an organization forward. If I get back at the question behind the question, then if you go back a few roles for myself, I was a data science coding, then became like a lead data scientist. And then I had an opportunity to work at another place as a principal data scientist. And at that time, that was sort of the highest data science. And I had a dotted line to the CEO. So it was a little bit more of like a leadership role, and then eventually transitioning more into how do you lead the teams? And then how do you move strategy forward for an organization? So I hope that helps.
Thank you. It was great to hear about how your organization is structured. Question number 2. So what made you interested in pursuing a career in data science? What were some of the challenges and opportunities that you encountered as you progressed to where you are now? Professor Cummings.
Sure, let me unmute. Like I think that I get this question a lot, which is like, you are at X stage in your career. How did you get there? With the kind of like underpinning question of kind of like, how did you achieve all these things on your track to get to your goal? And the like true answer is that I just like kept doing what I liked all the time, and I ended up here. Like I think that's the true answer, and that is maybe like the most helpful one, is that it's not that like there's some like life goal and like all of our panelists are like working hard and like ensuring that we achieve a goal, but rather like your job should be something that you think is really fun. And I've been fortunate that kind of like every step in my career, I just like did stuff that I like doing, and now here I am. I actually got to where I am through a somewhat windy path. I was a math major as an undergraduate. I just liked doing math, and I figured like I should do that. I didn't really think about like jobs and employability. And in some sense, I'm very fortunate that I happen to like doing STEM like activities, because there is jobs there. But I think at the time, data science wasn't a field, like it didn't exist yet. It's a relatively new direction. And so then I went to graduate school and I got a computer science PhD when I realized you can do math and call it computer science, and then there's more jobs, but you're still doing math all day. And it wasn't until maybe like partway through grad school, I sort of discovered there's this field, it's called machine learning. People seem to think it's important. I think it's interesting. And so that was sort of what I did. And I mean, most of my work focuses on privacy. And so I happen to think this is like a really important question for the world and in society. And as we're putting more and more of our data online, it's being used for things that we don't fully comprehend. A lot of machine learning is sometimes confusing and we don't really understand what's happening with the data. How do the outcomes depend on the inputs? And so I just felt like privacy is like a really, really important thing that we should think about formally and like carefully. And I also was sort of coming at this with my approach. Here's my skill set. My skill set is that I can do math and I can think about algorithms. And there are big important questions in the world that can be solved by people with a different skill set. But I was looking at like, given that I have a skill set and I like doing things in this space, what kinds of problems can I solve that I believe would be an important and impactful addition to the world. So that's kind of how I got here. Is it was always sort of like, what do I like? What are my skills? And also like, what do I think is important? And I had like heard this quote that I love and I still think about as I make life like decisions now, which is a kind of like, you can be anything you want, but you can be more of what you already are. And so I sort of thought about that as I was picking research topics and career choices. As I was saying, I like math, I'm good at doing math. I could try to be a software engineer, but I would have to like learn how to code first. And like, that's a lot. I would have to learn all the other things, get experience. And I was thinking, what am I? I am like a mathematician and I want to continue being that, but I also care about the real world impact of my work. I don't just want to like, do math for things that don't matter, but I want things to matter. And so these are sort of like the core principles that like, drove me is I want to find a career that will build upon my skill set. And I want to feel like the things I'm doing every day matters. And so like, here I am. For part two of the question, some of the challenges and opportunities I encountered as I progressed, I think a lot of the opportunities are still there for folks in the audience, which is that like data science is a pretty new field as things go. I mean, if you compare it to like biology, that's been around for a very long time. Data science is very new, which is exciting because that means there's like a lot of problems that like the world needs to be solved. And there's like not very many people who like have the skill set to do it because we're just now developing the tools and learning the skills. And there isn't a person who has been doing this for like 60 years because like the field hasn't been around that long. And so you really can like get in on the ground floor, which is like fantastic. It's exciting. That also presents a challenge too, which is it kind of like you are like by definition getting into a field where like there's not that many experts and there isn't always a person to like turn to for help, because maybe this is like a tool that was developed a year ago and it's brand new and it's exciting and like no one is an expert in it. So I think that is sort of a big one. Like there can be a plus or a minus. Some of the challenges. One thing that I always think it's important to just like say out loud as many times and as publicly as I can is about imposter syndrome. Good. Like I see that I'm seeing some nods. And so if you haven't heard of this, it's a feeling that somehow like everyone around you is like smart and the best, and you're like the dumbest one in the room, and you're like the one person who like shouldn't have gotten hired. It was an accident, shouldn't have gotten into the school. Everyone else knows what they're doing and you don't. But the secret is literally everyone is thinking it. And so it's not that like you yourself are like, uniquely bad or uniquely unqualified, but rather just like the world is a confusing place and we're all just like trying our best and we're all trying to like, perform competence. And like, the people around you are human and they're like at the same place as you are. It's yes. And I feel like the more that we all like, say out loud that we all feel this way, the less it feels like a personal failing. And the more it becomes just like, this is something that like, everyone struggles with and kind of everyone questions.
Thank you very much. Jeff.
What a great answer. And I'm going to start backwards with this imposter syndrome comment. I love that. There are certain fields in school that will kind of drive this home every day. You'll walk into a room, they'll go into a lecture, and there's going to be gibberish on the board, and everybody's nodding, and you're saying, "What on earth am I doing here?" So there's some of schooling that'll sort of prepare you for that, especially in math. That happens a lot, where specialization in some fields can just overwhelm even experts in other fields. So what made you interested in pursuing a career? I never pursued a career. I fell into it. I got into math again because it was something I did fine in school at. I went to grad school kind of on a whim, and then several years later, I found myself graduating. Immediately after grad, I never wanted to be a professor. I went into a math program, but unlike everybody else, I had no interest in it. I just wanted to get the degree I didn't want to, I wanted to study more. So I did. When I left school, I wanted to get away from academia. So I joined this LIGO group. And when I met with them, what really got me excited about what the project was there were physicists doing things with lasers in evacuated chambers, and there were engineers, and I was just like, where do I sign? I will mop the floors if you paid me to. This is so cool. So my first out of school time was doing basically the plumbing for this project. What came out of it was, my contribution was still in production years after I left, and when LIGO had the first discovery, I know that my code was involved in part of that process, and that's why I signed up. The next sort of more data science-y thing I got involved with was fraud detection on internet traffic. The premise of this is that the internet is an extremely valuable place. What drives it is money from advertising, and search is free because of the value of your time. Basically, people are paying for it. This attracted fraudsters. And so what needed to happen was kind of a data science oriented activity. We needed to detect signals in raw stream of data, but there was no textbook, there's no theory, but it has to be principled, because if you're detecting fraud, then somebody's not going to get paid. And you need to explain to non-technical people why you're saying that money isn't going to transfer hands. And that can be a tough conversation to have unless you've got that is a tough conversation to have. And you need to have your story about what's happening in the data very clear. And so that was kind of my first data science-y job. I actually don't remember what my title was, but that was definitely, it was not business analytics. It's kind of a gray zone between that and data science, but it was, feature detection. And this kind of segued very naturally into other kinds of data science-y activities where you're trying to find structure in semi-structured data. And that evolved into kind of a more proper data science role. Throughout my time, I've always kind of been fortunate to collaborate with people in academia, professors who are writing research papers. And, you know, being in the industry, you have access to data that people who are outside of industry don't have access to. And data is extremely important, even for academic researchers trying to do things, especially people at the time, it was internet traffic that we were looking at. That was pretty rewarding to be able to do that, and I'm still continuing to do that here, although it's in a much different data space. I'll move on to challenges and opportunities. One of the opportunities was the ability to collaborate with people inside and outside of academia. I've really enjoyed and benefited from that. One of the opportunities also is to find people who are doing things that are well beyond whatever I can do, and try to get close to that, just to either pick up their habits or learn new skills or something like that. One of the challenges, I'll mention two challenges and then I'll stop. The first is to kind of echo the professor's comments. The data science is very new, and a lot of it is, and I don't mean this negatively, but it's alchemy. It's kind of outcomes based. And so you do something, you tweak something, and then you see what happens. And if that works, then you say, that's success. And then you sort of go down that path. And that can be, it sort of makes you into technician, and that's not fun. And there's lots of fancy tools that sort of make this easier. But at the end of the day, that is kind of what a lot of it is. And that's a challenge. Like, you need to find something, at least I find more satisfaction when I actually understand, you know, in like digital signal processing, you can talk about things like smoothness. And if you've got a smooth signal, then you know you've got an algorithm that'll approximate it really well, very quickly. There's not that same sort of structure that you can hang your hat on in data science land. And the other challenge is sort of more practical. The toolkits are just changing all the time, even the ones that have the same names. The APIs are changing version to version. The model architectures are just different now than they used to be, and it's simply not possible to keep up with the sorts of things. So, like in AWS, for example, that didn't even exist, you know, not too long ago, and now it's this powerhouse, foundational to the ecosystem. So yeah, I'll stop there.
Thank you very much. Frank.
Yeah, so we're all very diverse, but I think we all have a similar answer on this one. And so I think I'll echo what Professor Cummings and Jeff have shared around, you know, I didn't start out with pursuing a career in data science. Actually, when I was in graduate school, that wasn't even really a term that people used. There was this concept of becoming a quant. That was kind of a big thing when I was I see Jeff laughing because, and they would just basically scoop up PhDs in math and engineering and have them work on Wall Street. And so that was a big kind of like the allure of, you know, could you do something else? So I fell into it in some ways, right? Working with lots of data. My research obviously then wasn't even in data science type stuff. I was in so our department's electrical engineering, computer science. I always remind people it's not a double major. So it's what other places might call computer engineering, but you pick up some hardware, you pick up some software. But I actually kind of leaned towards hardware. So I was doing more like experimental research with transistors. And I was working with lots and lots of sensor data. And I was just really kind of lazy as a grad student. And so, you know, I would set up my experiments and then I wanted to try to automate as much of it as I could. And so I wrote a whole bunch of MATLAB scripts. Probably in today's day and age, I'd be doing it in Python. But MATLAB, you know, had all these drivers where you could interface with the instrumentation. And so I just automated a lot of it. And then that generated tons and tons of data. You know, every 30 seconds, I would pull the sensors and then had to analyze it. So that was really, maybe that was data science, maybe not. I think probably in some ways you could call it data science, or analyzing time series data, analyzing the variance of it, and trying to detect, how these sensors were working. So I think, again, it's being flexible, as others have shared. And I think one comment that I'll make here, I think this is really helpful to say in the context of a career panel. A lot of times people ask me, what should I do when I graduate? What kind of job should I have, right? And they're really asking, like, what should the title of my position be? But I always like to turn around and say, well, what kind of work do you like to do? Do you like to sit at the computer? Do you like to interact with people? Because the truth is, you can be a doctor, like a physician, and be much more like a programmer, in the type of work that you do, right? I work with one radiologist. He was a Cisco engineer for the first half of his career, and he's more about computers, right, as a radiologist. And then you could have a different title, you could be a project manager, but I work with someone in HR right now, and she's HR and does a lot of people, but she's an analytics geek, and she's always pulling up spreadsheets and just kind of calls herself a fly-by-night analyst, right? So it's a lot of times it's the type of work, and I try to get people to think about, don't focus so much on the position or the title, but what are the kind of things that motivate you? Is it diving into data? Is it answering questions? Is it working with people to try to understand their needs? So I think that's one thing to think about. If I jump to the challenges and opportunities, I would echo everything that's shared, like what Jeff said around data science can be somewhat esoteric, hard to understand. The tool set is always evolving. I'll add another one, and this only recently occurred to me in the last few months, because I've got a lot of people now, both professionally and personally, that are asking me about, hey, should I get into data science? They're looking at these boot camps and whether or not I should pay X amount of money and kind of get a career degree in that. And one other thing I will say, this is a little bit more pragmatic, more practical, when you're really in that process of looking at jobs. But I think it's actually quite important, and it didn't really occur to me for a while. But when you say data scientist, that means different things for different organizations. So let alone people. So I imagine, like, Jeff's role as a data scientist in a large Fortune 500 insurance company, they have a certain concept of data scientists that might be very different than how the healthcare system might think about a data scientist, or how Amazon thinks about data scientists that are working in a digital native company with lots of web analytics. So, like, if you've been in a company that's insurance, like, there's a great heritage with actuarial science, and maybe that informs how the company views that unit and the role that unit plays in the business. And so I think one thing I always tell people is be very flexible when you think about data scientists, and even in your job searches or when you're having interviews, ask them a little bit about, where does this data science team sit in the organization? And you can learn a lot if you just ask questions like, who's the boss of this? Are they someone that's more in IT, or are they someone that's more in finance? And that'll give you a sense for the type of role that's happening. And I think this will continue to be true. I don't think there's ever going to be a data scientist like in the way that you think about, like, my wife is a pharmacist, right? And she's worked at CVS, she's worked at Shopko, she's worked at and so in every company she goes to, they might have different but the pharmacist workflow is relatively the same. You fill scripts, you consult patients. It doesn't, in a sense, CVS versus Walgreens, some different dynamics. So I use that as a contrast, right? In data scientists, I would not make that claim. Like, your type of job in one organization might be very different in a different organization. So that's just some practical advice to think about as you look at specific opportunities. So ask some questions about, how does this role play out in the organization? Ask some questions about who's the boss, where's the management, what department do they sit in? And so I don't know if I would call that a challenge, but I just let people know that. And I think it comes back to how many of us got into this field, which is that you have to be flexible. If this is the kind of direction that you want to go in, just realize it's a kind of position that will evolve over time. Even you join that organization, they're like, oh, all our data scientists are in finance and they do this and that. You never know. 3 years, 4 years later, they hire some other people, they reorg their data science function. I mean, that's happened before, right? Because data science itself evolves. They realize, oh, there's other opportunities here. So some of my top advice here would be flexible. Think about, just like Professor Cummings said, like, what you like to do, what you're good at. always keep that in front of you as you think about your different opportunities.
Thank you. Sarah.
Awesome. Thank you. Wow, the challenges. Goodness gracious, we are so aligned, even though we're so different. I'll get to those in a second. But first, how did I begin to pursue a career in data science? We'll call it for me, even though I mentioned before it's not quite data science, but that is a vein of what I do. So I started out as Casey mentioned, I studied industrial engineering at UW, and I actually was planning to be a manufacturing engineer. I was really motivated to be hands-on in the plant and be a pioneer for women in manufacturing. So prior to my last semester of college, I worked with GE Healthcare. It was it's really amazing role, worked with a lot of really great people, and they gave me an offer to join the team, which I accepted going into my last semester. And my last semester of college, I took Justin, I actually don't even know how to pronounce his name, Boutlier, his class at UW-Madison. It was machine learning in action. And I had been pursuing my comp sci certificate, but I had never done anything like machine learning. So it was brand new to me. So here I am taking this class because it kind of sounds cool and interesting, but I was about to graduate and I had my career plans all lined up. I was going to go work at GE in the plant. I took this class and it really opened my eyes to just the future of technology. Some of the case studies we learned about with Netflix, UW Health, really inspired me. And so I started to think about, in the air of Rachel's advice, kind of like, what do you like doing? Frank's advice, who is it that you are? What do you like doing? I realized that what I was really pursuing was innovation and being able to be on the cutting edge of innovation. And granted, manufacturing industries, they're innovating faster than ever. But I think we can all agree, not at the pace of Amazon, the cloud, data science, right? It's every single day, like Jeff said, there's something new. The speed of innovation is rampant. So what I did, and I actually want to kind of spend some time talking about this actually, because I feel like it's not talked about often, and that is like the job search. So I graduated in December 2019. I had this offer for GE, which I had accepted, and I realized I wanted to pursue a different career. So when I graduated mid-December, every single day, I was applying to 10 jobs a day. And I'll get to why that might be a little bit, you might not need to do 10 jobs a day. I was basically throwing stuff at the wall, seeing what would stick. But I was also pursuing data science certifications, trying to get some projects under my belt, working with data more and more with different boot camps and things. So I guess I say all that just to let you know that, like, I decided last minute to pursue data science. And I guess sort of like Jeff, I guess I fell into it in some ways, but you could also say that I actually like really put some time and effort into getting there. And it worked out. But I was rejected a lot. So 10 applications a day. I probably heard back from maybe 10 companies, all but 9 of them, right, rejected me. And then I got Amazon Web Services. So I guess one positive of throwing spaghetti at the wall and seeing what sticks is it gives you the opportunity to get your foot in the door and see if there is a spot for you, see if what the job that they're offering is something that works for you. I won't get into the details, but I actually did get, I was put or slotted for a role at AWS. And a couple months in, my manager, who was really inspired me in a lot of ways, because he was pro my career and pro me rather than pro his organization. And he said, you know what, Sarah, this role that you're in, it was more of a heads down role, where I was going to be actually coding, building solutions for customers, AWS customers. He said, you know what, I think you would be better customer facing. I think you have the social skills. And I could just see you thriving there more than you would thrive here. I don't think you would thrive here like you think you might. And I took that into consideration, and I'm really grateful that he brought that up to me. And so anyway, so I did actually end up changing my job. Only a couple months into AWS, I became a solutions architect. And now I have pretty much all day I'm talking to customers. So I get to kind of scratch that social itch, the extroversion tendency that I have. So that's, I guess, how I got here. Challenges, imposter syndrome number one. So the current team that I'm on, I'm the only one under 30 and I'm 24 and I'm the only female. And every single other person on my team and my extended team has at least 20 years of experience in the industry. So they've been selling at Microsoft, selling at Cisco, selling at Dell, back when they were selling like hardware. So they've seen the progression of tech in the industry. And I come in, I don't know anything about that. I just know about the cloud. But what I've learned to do, and some days it's easier than others, is to really just lean into that discomfort and that imposter syndrome. And, you know, you don't need to say like, oh, I feel uncomfortable here. I don't understand this. You don't have to say that. You don't have to draw attention to the fact that you're feeling like an imposter, but what you can do is ask for help. Ask questions. And luckily, I know it's not always easy for everyone. Rachel mentioned that in her industry, everything's so new that there's not a lot of people who are experts. It's different for me over here. Everyone is open to talking. And you'll find, at least from my experience in tech, people want to share their knowledge and they want to teach. There's just something about people who are passionate about data and data science. They just want to share their knowledge with others. So to sum it up, imposter syndrome, lean into it. Ask questions when you don't understand, spend more time learning, and just acknowledge the fact that you're probably going to always feel like an imposter. You just have to get comfy with it. But then secondly, echoing what Jeff said about innovation. Yeah, that's one of my biggest challenges. And what I do is Amazon Web Services has over 200 services now. And I'm expected to be a subject matter technical expert on all of them. So the pace of my learning does not come close to meeting the pace of innovation, but I find that that excites me. And so that's another thing, that, we have to consider is, are we willing to deal with that pace of innovation? We have to get comfy with that. I realize I'm like, keep talking and it's 2 minutes too. So Casey, I'll hand it to you.
If I can, I would like to add one more thing. Thank you, Sarah. It's so nice to hear all these things agreed with. And one thing that I want to add is that while I think everyone experiences imposter syndrome to some degree, if you are a minority group, however you want to define minority, it's worse. basically, if you look around the room and you think like, there's no one here like me, along kind of like, whatever dimension and like access is important to you in terms of belonging, that makes it harder. And so like, thank you, Sarah, for saying like, gender, age, many other differences. If you feel like I'm the only one for my group, that makes it harder. And, I think I personally have been very fortunate. My colleagues and peers have been really wonderful and really accepting. I know that's not the place in every workplace, but I hope the workplaces are moving in a space where they're being more inclusive and more kind and more like everything that you want, which I think will help a little bit of these like imposter syndrome things of just the like support and the camaraderie.
Thank you very much. The next question we're going to talk about is this. So many of those that are attending this session are students, and others are working professionals who are considering a career shift into data science. So what skills, internships, or experiences are most essential for someone entering the job market? Okay, so Frank, could you get us started on that one?
I'll start with kind of a broader, curiosity, interest in data, wanting to solve problems. And then if I move kind of towards the spectrum, I think in terms of technical skills, being able to, you may not need to know a specific language, but being able to write some code to help work with data, to manage data. So depending on what kind of job or area you're looking at, some of the top ones are, you'll often see things like R and Python. Again, I think I'm a little old school where sometimes I think it's better to understand the concepts behind it, and then you can pick up the languages that you need. But those are two definitely different ones in terms of, if this is a very pragmatic question of like, I'm applying for jobs, you'll definitely see some of that. Another one that's really, really important, and you may have picked up on this in some of the answers, right, is communication. That's a really key answer, especially around data, right? Because in some ways, a data scientist is someone who uses data to tell a story. They use data to answer a question, to help present an insight. And so the ability to communicate is really, really key. How can you get an idea across in a clear and concise way? Can you also ask good questions and solicit feedback? So that's another key skill that I would highlight. I'm kind of tempted. I'll just make a quick comment here, right? There's a difference between exploratory analysis and saying, okay, here's like a whole bunch of code, and I took this data set and I like ran this and ran that, ran this and ran that, and this is what I got. And you're just showing this output of work versus kind of flipping the script and saying, okay, so this is the question that you've asked. Like maybe I explored some categories here. I explored, maybe I did a regression analysis. I didn't find anything. So actually I don't need to talk about that, right? I'm going to put the center of reference around, these are the insights that I came up with, or these are some of the answers that we have. And it's not so much a, I did this kind of style, right? So that's just an example of how important it is to communicate and not just throw data at people, right? But what is the key takeaway, or what is the question that you're trying to answer? Let's see. So those are all really important skills. I think going back to some people, with what Sarah, Jeff, and others have highlighted too, an ability to continue learning, to continue to want to learn. That's both on the technical side as well as, I think, in terms of professional development, wanting to grow, take on new skills, learn new areas. Data science is oftentimes not a domain in itself, but it's data science applied to a specific domain that makes it really powerful. And so being able to understand that domain. So those are some of the key skills, I think, especially if you're just getting started. Those are ones that will, I think, come up as you talk with employers.
Thank you. Jeff.
Yeah, getting started in data science, I think, is different from having a career in data science. So to the difference is getting your start is having a set of skills, getting employed somewhere, and then, you know, wherever that takes you. But to have a sustainable career in not just data science, it's pretty broad. Like, you have to have a positive attitude about your work and what you're doing. You know, because especially in data science, whatever the hot language is today, if it's Python or R or whatever, it will be different in 5 years. The libraries that are state of the art today are probably already obsolete. The tasks that are innovative and novel and everyone's talking about are going to go to the wayside. So to have an actual career, you're going to have to simultaneously work to stay current with whatever is relevant. In 10 years, if you don't do that, what will happen is somebody fresh out of school is going to be hired and come in behind you, and they're going to know all this stuff that you've never heard of before. So don't let that happen, is my word of advice. And the other is just a quick comment is to be very open to feedback. You know, it's hard to take sometimes an honest assessment of who you are, what your strengths are, what your weaknesses are. But if you trust the person who's delivering it, then it's sometimes hard but good to be open to their judgment if it's honestly meant in a constructive, helpful way. So yeah. I think I'll stop there.
Thank you. Professor Cummings.
Yeah, so I am in a somewhat odd position because I help prepare many students for the job market, but I have never applied for real jobs myself. So I can sort of give like a two-part answer. The first is sort of like what I see of my students as they apply for jobs, and some of them do or don't. I mean, I feel like mostly they all do. But like, you know, the things that really seem to make a difference are like taking courses in it, whether you are a current student and you can take some courses in it. I mean, it sounds like this is basically Sarah's path, is you can, like, you know, take some courses in it at your like university. If you're not, there's lots of like, you know, courses, certificates, boot camps. They vary in price. A lot are free, some are quite expensive. And there's kind of like, you know, everything between. And so I just think getting more like training experience, certificates are going to be really, really helpful in that, because we don't have like a formal, like, you know, there's like very few schools that offer a degree in like on data science. The way that you show competence is through these like other like, you know, certificates and things like that can be gotten online. Check out MOOCs, MOOC. It is basically a course taught at a top university that is sort of like, you know, open source, available, can be done like in your own time, usually free, and just kind of like massive, massive online open course. It's basically like, you know, a giant course and like an important topic that's kind of open like to everyone. So I think that's one thing. Like I'm also just experience and even doing small projects, and it can be either like, you know, a course project if you're a student, it can be if you're employed. Is there some like, you know, very small project that you can take on in your current job, even if it's like, you know, outside of your typical roles? Like if you say our like, you know, printer in the printer room processes people's jobs in the wrong order, and like that seems like it should be fixed. You know, it's even if it's like totally outside of your like job, thinking about how can you use data science in those ways, or if not, just do like, you know, a fun project I'm gonna like, train a predictor on my Spotify history to see what new songs I might like. And like, that can be done in your free time too. And so I think that is also like experience, basically like the more experience you can show, whether it's through formal training that gives you a certificate of completion, or if it is like a project that you can like, talk about in your job interviews, and you can also gain skills in that way. And like part two of my answer is going to be, if anyone is interested in going to graduate school, I think the same advice applies. The more that you can show good grades and certificates and training and background, basically just to verify if we admit you, you have the background to be successful in the courses. And that's mostly for master's program. For a PhD program, it's good to get some kind of research experience. And I think the same thing applies. If you are a current student, see if you can do research with a faculty member. If you are employed, is there some part of your job that can incorporate research questions? Or if not, think about your own research ideas and do like a small project on your own. It's always harder doing things on your own. There may be some guidance online, or see if there are people like in your life, professionally, personally, who can serve as a resource for that as well.
Thank you, Sarah.
Awesome. I think I think it's all been said, and our panelists gave great advice. So I guess what I can add here, granted, I guess keep in mind, I'm speaking from someone who interviews candidates at Amazon. And again, I'm not a data scientist. So if you're looking for advice on how to become a data scientist, I can't give you that directly. So I would default to what our wonderful panelists have provided here. But if you're looking for a job, I think in general, this advice applies. One thing that I guess two major things, besides the technical competency, right? And you've probably heard this before. I think interviewers really like to see passion, and they want to see you take an interest in something. So whether it is a project, like Rachel said, that you're doing on your own with your Spotify history, maybe it's a school project, and that's what I used in my interview for Amazon. I used a project that we did in the machine learning class I took at Madison, and I presented that to the interviewers. Or it's a project you did in an internship. Bring color to it, bring excitement to it. I think it really helps you become memorable, and it helps you come alive. And they can see you in that role even more if they see, that you're excited about it. Secondly, and here I'm going to get a little specific with, I think, Amazon, I guess as an example, but again, it can apply anywhere. So at Amazon, we have something called leadership principles, and there's 16 of them, just added 2 additional ones. Amazon, in my opinion, is unique because it's the only organization I've ever worked for that really, really holds fast to those principles, which is really cool and inspiring for me. But those principles make up the questions in the interview. So all behavioral questions are basically tailored around those leadership principles. So what I did when I was preparing for the interview at Amazon is I thought up a story or reflected on my experience and identified a story in which I could use to demonstrate each of those leadership principles. I think the same goes for a lot of organizations. Every organization has founding principles or I don't know, like morals that guide them. I believe that they're generally going to use those to see if you're a good fit. For sure, it's important to have the technical competency. But I think, dare I say, equally important is to be a good fit and just to be a good human. So whatever you can do to prepare for those types of behavioral questions is really, really, really going to be valuable for you. And when I say prepare, I say like you should put just as much time preparing for that as you prepare for the technical questions or the technical presentation.
Casey, I'll add a little bit here. I feel like I owe it because I heard skills when you first asked it, but then realizing that this is a broader question. So I'll add a little bit more to the actual question, but it's actually a lot of the same of what others have said in terms of going beyond skills. It's the experiences. And so I think, at least as I see it, I can give my perspective here with an N of 1, but like I would agree with Jeff in that I think someone who's just starting as a data scientist is different than someone that's experienced and you're looking to bring them on. I think there's just a big component of hands-on training. So if you're talking about someone who's just coming in, so we talked a little bit about the skills. I also agree with what Professor Cummings said. If you haven't picked those up through degree work, those certificates are really helpful for that baseline. And I would also add here that sometimes those are beneficial because it does show a certain amount of passion. Like Sarah would say, like a certain amount of initiative that I know catches my eye a lot. Sometimes if I'm looking at things from a hiring manager's perspective. And then the experience part of it, I'll just share a little bit about that. I think that does come back to just having projects. You may not call them data science projects, but just, again, this idea of taking data to information to action is one that we talk a lot about. And so, for example, one of the questions that we like to ask is, how have you used data to change a decision or to help inform a decision or change an action? And I think some of those other pieces are really important. And it's not just munging through a data set, but being able to engage and have those conversations as well. So those and those are the kinds of experiences that you can look to have outside of just, this is my coursework, this is the skills, I know how to code and do that. And those are good things to highlight, both in terms of, previous experience or in the course of an interview, and being able to show how you can engage, how you can use data, how well you can have that curiosity and that passion. It's a really odd process that we have, that you talk to someone for 30 minutes, 60 minutes, and then you make maybe you do a couple rounds, but, still at the end of the day, it's like, less than a handful of hours potentially. Maybe you spend half a day with the person and then you make this big decision, like, is this going to be your job going forward for 8 hours a day or, 5 days a week kind of thing. So it is a very odd process. And so I just want to underscore also not to be discouraged. And I can also tell you that a lot of times there's things around timing that may or just be out of both sides' control. And so I've just had a lot where there's a really good candidate and it's just not the timing in terms of, when that opening is there. And it's, and there's always constraints on both sides with timelines and are we ready to do this? And so just because you have a rejection there, it does not mean you're not a good candidate. There's a lot of times when it's really out of, it's just not, there are constraints. And so I would not take it, don't take it hard, right? We talked about imposter syndrome. I like what Sarah shared around just keep applying, just keep working. And even personally, we've had situations where it didn't work out that time, but people stayed in touch. And then later on, there was a different opportunity that was more of the right fit. And so we can have another conversation again. So there's a lot of idiosyncratic aspects to the process that aren't reflective of who you are and your skills and your talents. So just it is not a perfect process. Don't let that be a reflection of how you see yourself or your value.
Great, thank you. We do have a little bit of time left. If any of the audience members has questions, feel free to put them in the chat. While we're waiting, one thing that comes to my mind is that there's a lot of data science educational options out there, from really intensive boot camps and certificate programs that we've talked a little bit about, all the way to formal advanced degree programs. So are certificate programs and boot camps good options for people hoping to get jobs in data science? And what are the general educational requirements for someone wanting to pursue what you're doing, or someone that's wanting to pursue something like one of your other team members are doing? And this is just an open question to anyone.
Well, I can speak first, again, just from my perspective, not necessarily being directly a data scientist. Remember, I think I just want to index again on what Professor Cummings said about a project. Make sure you have 1 or 2 projects at least, and you can create projects yourself. They can be just like passion projects. You can go to kaggle.com and find a data set, or use a data set that you have of your own history of some sort. But in regards to certifications, one plug I can make is for the AWS certification program. We have lots of courses and resources that are free to use, that you can use if you are interested in becoming AWS certified, not just to be an Amazonian, but to work in an organization where you are using AWS resources a lot. I imagine, and Jeff, you might have alluded to the fact that you're using AWS resources in your day-to-day. It's beneficial to have data analytics cert under your belt from AWS. But yeah, I'll send a link later. Yeah.
If anybody else has any thoughts on what some of the educational requirements are.
I'll give
Yeah.
two thoughts. Oh, go ahead, Professor Cummings, you go first.
Sure. So I can certainly speak to some of the more like formal degree programs if you're looking at like, master's or PhD even. I'll say first, like at least anecdotally in my life, and I say this not necessarily as a kind of like data science professional, but just like as a person who has like a bunch of friends who works in like data science fields, it seems like these like, trainings, whether they are like, boot camps or like free or cheap certificates, it seems like they work. I have like, a ton of like people in my social circles who have done various things in this space, and they have gotten jobs like pretty quickly after. So it seems like they work. I feel like I personally don't have as much of a nuance as to like, an expensive boot camp versus a free online program. And I think some of the other panelists may have like a better sense there. But in general, they seem to work, and people seem to kind of like get jobs from them. I can speak to the like, higher education options. There's a kind of growing number of schools that will have a formal master's degree in like on data science or machine learning. I know that like Columbia, we do, and so I will certainly advertise that. We do have I think it's a like 1.5 year program. Had my former institution, I was faculty at like a Georgia Tech before this, and they had a master's degree in like a business analytics, which is what they call data science. I think this is like another thing to note, is because data science itself is a new enough field, kind of like not all things that are doing data science are called data science. And so you may want to look for some other buzzwords: analytics, machine learning, data science. Any of these things with like appropriate sounding words are probably going to be data science. So I know that like Georgia Tech has one that is they have an option for being either in person or being online. And so I know especially the kind of online one, it's very popular and it's very affordable because it's online. Those are just the two that I had experience with. I know there's a growing number of schools that are offering formal like master's degrees in this space. I know from both of those programs, graduates get really good placements. And I imagine this is true kind of anywhere, especially given the demand for kind of well-trained data scientists. There's always jobs. So that's really nice. like if you're interested in doing a PhD, I'm happy to sort of like chat with people later if they're interested, because I imagine that's probably a separate conversation. So kind of if you are, feel free to like email me. A PhD is like, you know, a 5-year commitment, and you need to really love doing research. And so I would say if you want to go out and get a data science job, don't do a PhD. If you want to think about research and like, you know, understand the frontiers of the scientific knowledge, do a PhD. And those are two very different goals, and you should pick the one that is appropriate for your life goal.
I'll just add 2 thoughts here, because I know these are really, really popular. And so I think one is kind of what you get out of the degree or the boot camp. So, you know, learning some of the skill sets. Like I said, sometimes that to me is going back to some of the mechanics, like learning to code in R, Python, Scala, or Spark or something like that. And then I think the second one is the meta level of the initiative that's being taken with putting the time and the effort into that certificate. Actually, the second one oftentimes resonates with me a bit more when I see that. And like Sarah's point out, you can always have your own projects, and people nowadays, you can put your code in the GitHub repo, right, and have that there, and someone can take a look at it. And again, a lot of times if I look at that code, there's the nuances of the data and what you're trying to do, but then again, it's just seeing the level of output or kind of the initiative around that oftentimes is what resonates a lot. The other comment I'd make is they are newer, so I don't like, again, N of 1 here, but there isn't like one certificate or boot camp that I go like, oh, this is the one, and if you go here, you're gonna get like, you're gonna check off every box, and this is the one we funnel people to and all that. So I see a whole mix, and so right now, I just take it at that level of, okay, they've done this camp, there's probably some skills that they've learned, and then there's the initiative that they've shown. Will that always be true? I don't know. We'll see in terms of time, in terms of how degree programs evolve and how certain certificates evolve. But for now, it's, if you ask me like, what is the top 3? I wouldn't know, at least in terms of how, from where I sit and how we evaluate people.
Thank you. So I don't see any questions in the chat from our audience members. And in fact, we're out of time. So that actually concludes the 2022 career panel. And I'm sure I speak for all of us when I say thank you to the panelists for taking the time to share your thoughts and experiences. And feel free to use the reactions panel to give them a round of applause. I think I'm going to do that. Thank you so much. Jason and I are going to stick around for a few minutes if you want to chat. And as a reminder, a recording of this panel will be made available via the Research Bazaar website at the link that Jason is going to post into the chat. Thank you for joining us today.
Thanks, everyone. Best of luck. Rooting for you all.
Thank you, Sarah.
Thank you, everyone. Have a good day.
Thank you.
Agreed. Thank you. Yeah. Happy to
Great
be here.
meeting you, panelists.
Same.
Y'all are inspiring.